All right, so lesson 94 is uniform motion. So this is that new concept from last week, and I told you we'd be adding a few different versions of it that end up increasing the difficulty. So this is an increase in the difficulty. So last week we had equal distances. This week we're not going to have equal distances. We're going to have an added distance. So remember that distance equals rate times time. So if we're adding the distances, and this is one example of a kind of how we could add a distance, if something's starting here and going this way, and then something else is starting at the other end and going this way, when will they meet is a question that they might ask. We remember that distance 1 plus distance 2 is equal to number, just so whatever it is. And so that also means that the rate 1 times 1 plus rate 2 times 2 equals that same number. So that's kind of what we're having in mind. Now, as you do these problems in your problem set this week, you know some are going to be from the first section, some are going to be from the second section. So you're going to have to discern which ones are new and which ones are the older practice. So that's, a bit of difficulty too. All right, so let's read our practice first. Okay, so it says, an eastbound bus left Ukiah at noon. 2 hours later, a westbound bus left the same station. If the buses traveled at the same rate, so that's the same rate, that's a nice hint, and were 500 kilometers apart at 6 p.m., find the rate of each bus. So we're thinking about this. They're leaving at the same place, so they have a middle same place. One is going to the east, one is going to the west. They're traveling at the same rate. How far apart, what is the rate of each bus when they're 500 kilometers apart? And it says that the eastbound one left at noon, so that's a tip, and they're talking something about 6 o'clock. So that tells us that it is traveling for 6 hours, okay? The westbound bus left 2 hours later, so 2 hours later, and it also is at 6 o'clock, so it's traveling for 4 hours. So that's kind of what I'm thinking about as I go ahead and try to define this stuff. So I start my little picture. This picture isn't as great as I should have done maybe, but I probably next time would do like a center going east, center going west. So that's kind of what this is showing. It's just not as clear. So the time of the east is equal to the time of the west plus 2. Okay, the rate of the east is equal to the rate of the west. Okay, so that's something that we know. The time of the east is equal to 6 hours. Remember, I told you because it said 12 there. It's leaving at noon, and then it's getting there at 6. Or what's the rate when it at 6 o'clock? So that's 6 hours, and then the time of the west is 4 hours since it left 2 hours later. Okay. So I set up my equation, and it's DE, so the distance of the eastbound train plus the distance of the westbound train is equal to 500. It tells us that they're 500 kilometers apart. Okay, so then it says RETE is equal to RWTW, so I just did that substitution, is equal to 500. Okay, then I can substitute what I know. Now, I know that the rate is the same, right there. So I'm going to go ahead and try and substitute RE in for RW, and I could have done the opposite just to get us to have only one variable. So I have RE times 6 plus RE times 4 equals 500. Okay, I substitute the times in also. So I have 10 RE is equal to 500. Divide both sides by 10. RE is equal to 50 kilometers per hour. Okay, so there's kind of an overview. Make sure that you have this in your notes so that you can kind of reference it as you're doing these problems. Okay, next example. Okay, let's see how we start here. There we go. All right, so let's read. A train starts from Peoria at 2 p.m. and heads for Reedley, 750 kilometers away. At the same time, a train leaves Reedley and heads for Peoria at 80 85 kilometers per hour. If the train meets at 5 p.m., if the trains meet at 5 p.m., what is the rate of the first train? So this is one where they're starting in opposite towns and they're heading towards each other. And they're 750 kilometers away. And we're wanting to know some information about how fast the first train traveled in order for that other stuff to work. So let's remember the distance is going to be that the combined distance is 750. Okay. If the train starts at 2 and we're saying it meets at 5, okay, and both trains start at the same time, so the times are going to be equal and it's going to be 3 hours. Okay. It also says the Reedley train is 85 kilometers per hour. So that's the rate of that. And we're looking for the Peoria rate. Okay, so let's go down. All right. So I've got the rate of Peoria, which is the first train, plus the rate of Reedley is 750. I know that my time of both trains is 3 hours. I talked through that. Okay, so I'm going to substitute rate of Peoria, time of Peoria, plus rate of Reedley, time of Reedley equals 750. Okay, let's see what else I know. Okay, I don't know the rate of the Peoria train, that first train. I do know the rate of the Reedley train, right? And that is 85. So I do RP times 3, okay, plus 85, because we know that down here, times 3, because 3 hours, remember, for both, equals 750. You can go ahead and simplify a little bit. And I end up with 3 RP is equal to 255, just from that multiplication, equals 750. Subtract the 255 from both sides, right? Okay, I'm going to get 3 RP is equal to 495. Divide both sides by 3. So RP is equal to 165 kilometers per hour. And that's the rate of that first train. So again, here's the complete solution. Pause it, make sure it's in your notes. All right, I will be back with your next lesson. Goodbye.